Hi guys, I'm Arezoo.
And I'm Ixchel.
Today you are going to watch our presentation. Hope you enjoy it.
Yep.
The title of the article that we are talking about today is Development of a Mass Spectrometry Sampling Probe for Chemical Analysis in Surgical and Endoscopic Procedures. The paper is done in Purdue University in Indiana, and the impact factor is 6.042. Mass spectrometry is for analyzing complex mixtures at high sensitivity and selectivity. The recent development in ambient ionization method allow direct ionization of various chemical and biological samples in their native state. This method is compatible with MSMS, sensitive enough to identify the mixture component and precise in quantitation. Tissue samples MS imaging has some limitations, which one of them is sample preparation. MS imaging is becoming an essential tool in biomedicine, especially for quick tissue analysis or profiling, and with ambient ionization method can play a crucial role in this field. This study shows the development of sampling ionization probe, which is using a modified form of desorption electrospray ionization or DESI in a different type of procedures such as endoscopic and surgical. MS sampling probe could be enabled in vivo and facilitates the diagnosis and decision makings during the laparoscopic and endoscopic surgeries. For utilizing this sampling probe, the analytes on the tissue surface should be ionized and transferred over the long, thin tubes to insert through the probes for endoscopic or laparoscopic procedures. Analysis, sensitivity, and safety of the operation are some concerns related to the design of these probes. In this designed probe, the desorption ionization occurs on the surface of the sample, and observations showed that the ionized species with this method could survive in long distance surface by the gas flow from the DESI source. DESI is efficient in desorption ionization of non-volatile organic compounds and biomolecules directly from tissue samples. For facilitating the desorption ionization at high efficiency, high voltage, high velocity gas flow, and organic solvents used. But these conditions don't satisfy the safety requirements for endoscopic surgeries. In this study, the designed probe easily fits in the endoscopic tubes, and safety requirements are improving while the necessary sensitivity for chemical analysis is retaining.
For the experimental section, different tissues and samples were used, including rat brain, intestines, and kidney, and E. coli polar lipid extract. The solvents used in the experiments include pure water, methanol water in a 1:1 concentration, and pure methanol. For mass analysis, exactive Orbitrap and LTQ linear ion trap mass spectrometers were used. Here we have a design of the endoscopic probe, which uses Tygon tubing with an outside diameter of 3.17 millimeters and an inside diameter of 1.59 millimeters, with a length of up to 4 meters that was used to transfer the ions from the sample to the mass spectrometer. A coaxial fused silica capillary sprayer was made by inserting one capillary into another one. The inner capillary was used to deliver the solvent, while the outer capillary was used for the auxiliary nitrogen gas flow. The front end of the capillary sprayer was inserted through the wall of the Tygon tubing, as can be seen in the red circle. During the sampling for analysis, the end of the Tygon tubing was pushed against the sample surface with around 3 millimeters between the sprayer and the surface of the sample. When pushed against the sample surface, the soft edge of the Tygon tubing sealed the surface. The spray solvent and the auxiliary gas were contained inside the tubing without leaking. For real clinical application, custom designed tubing with proper outside diameter needs to be made for specific applications. Now, for results and discussion, an initial test was done under typical conditions for DESI. Using high gas flow rate at 0.43 liters per minute, using methanol water solvent as spray solution and a high voltage of minus 4.5 kilovolts were applied to test the efficiency of the desorption and the transfer over a long distance using the Tygon tubing. Probes of different lengths were made and tested for analyzing rat brain tissue sections. Excellent signals were obtained from lipids and fatty acid with a probe length of 4 meters, which is sufficiently long for endoscopic probe. The time delay between pushing the sampling probe against the tissue section surface and obtaining the signal was about 0.5 seconds. The mass spectra of white and gray matter are shown in figures 1b and c. The profiles of lipid and fatty acids observed are pretty similar to those previously reported for DESI analysis. Although adequate transfer efficiency was obtained for the analyzed ions from the sample, the conditions for desorption ionization needed to be altered to become compatible with the safety requirements for the endoscopic operation. So a series of studies were done to characterize the roles of the organic solvent, high electric voltage, and the gas flow rate, on the basis of which the alternative conditions were suggested and tried experimentally.
Previous studies showed that DESI analysis with methanol water provides significantly higher analyte signals than with pure water. The results of a comparison study using the analysis of half microgram of a lipid extract sample on a Teflon slide are shown on this figure. The high voltage of minus 4.5 kilovolt was used, and the rates for the solvent and gas flow were optimized to get the maximum signals in each case. In figure A, the signals of plasma were 3 times higher with pure methanol than with pure water when the DESI was performed at the MS inlet. However, the relative intensities were reversed when using a 4-meter long probe, which is shown in figure B. The signals observed with pure water were 3 times higher than those with pure methanol. For better understanding, probes of different lengths were used for this comparison study. As shown in figure C, the signal of plasma with pure methanol as a spray solvent has a decreasing trend as a function of probe length. For pure water as the spray solvent, the signal increased when the desorption ionization occurred 50 centimeters away from the MS inlet. Overall, the DESI with pure water had better performance with probes of long lengths. This observation could be explained with the dissolution of the spray droplets and formation of the analyte ions with DESI. When the droplets containing the analyte ions are transferred over a long distance, better dissolution could be achieved through collisions with gas molecules during the transfer, and the gradual dissolution might also help to protect the ions from losing charge through reactions. This leads to an overall advantage of using water instead of methanol as a spray solution for DESI in the design of an endoscopic probe. The efficiency in generation of the secondary dry ions after desorption is dependent on the size and the charge density of the primary droplets, which are subjected to the spray conditions, including the voltage and the gas flow speed. A comparison study was first done with the desorption spray source close to the MS inlet without transferring with Tigon tubing, where 0 volt or minus 4.5 kilovolt was used for spray, while the gas flow rate was varied up to 1.75 liter per minute. The sample of a half microgram of lipid extract on a Teflon slide was used for the analysis. Methanol water was used as the spray solvent. The intensity of plasma PE was monitored as a function of the gas flow rate. As shown in parts A and B of this figure, at a low gas flow rate, the desorption spray ionization significantly 30 times higher from the application of a high voltage. However, the impact by the gas flow is much more significant when there is no voltage applied for the spray. At a flow rate of 1.5 liter per minute or higher, there is no significant difference in desorption ionization efficiency between applying a high voltage for a spray or not. Ideally, the use of higher gas flow rates would lead to further increase the desorption ionization efficiency. However, practically this was difficult to achieve for desorption ionization performed close to the MS inlet, since the dispersion of secondary ionic species from the sample surface becomes severe and results in a poorer sampling by the MS inlet. Using a sample probe with its end sealed with the sample surface, this is not a concern since the gas containing the ions is forced toward the MS inlet. As shown in Figure C, the signal for the analysis with a 1 meter probe could be further improved by one order of magnitude between the gas flow increased from 1.5 to 5.5 liter per minute. There is also no difference for applying a high voltage or not for the spray, as can see in Figure D.
With the understanding of each role played by the spray solvent, spray voltage, and the gas flow in the desorption spray ionization, a 4-meter sampling probe operated with pure water, no spray voltage, and at a gas flow rate of 5.2 liters per minute was used in performance comparison with DESI close to the MS inlet under a typical optimized condition. This is using methanol water as a solvent, high voltage of minus 4.5 kilovolts, and a gas flow rate of 5.2 liters per minute. They were both tested for analysis of rat brain tissue sections. The quality of the spectrum compares well for these two methods in terms of the signal intensity and the species identifiable with the spectrum. As a test for potential applications with endoscopic diagnosis, analysis of the mucosal surface inside the fresh rat intestine was performed using a 1 meter long probe under the biocompatible condition for desorption ionization. Besides the fatty acid and the lipids, peaks at strong intensities were detected for the bile acid and dimers of the fatty acids, as can be seen in the figure. The potential carryover between analyses was also characterized by moving the sample probe between the surface of the intestine mucosa and the latex glove. They found that the signals due to the chemicals on the previous sample disappeared completely 4.5 seconds after the probe was moved to a new surface. After all these analyses, the damage to the tissues by the gas flow still needed to be addressed. To make the in vivo analysis minimally invasive with the sampling probe, this issue has to be addressed while retaining good sensitivity for the analysis. So a modification to the coupling of the sampling probe to the MS inlet was developed as is shown in the figure. A diaphragm pump was used to add a pulling force to drag the gas toward the MS inlet. In a test with analysis of fresh rat kidneys, no visible damage was observed using the probe with the pump, as can be seen in the pictures. To conclude, biocompatible sample analysis probe derived from DESI and long-distance ion transfer method was studied. Optimizing individual roles of voltage, spray solvent, and gas flow was done. Much further development is needed to convert this probe to an actual device in clinical diagnosis.
Okay, guys, thank you for your attention. And just if you have any questions, please ask. Thank you.